Hello everyone, welcome to our channel. Today in this lecture, we are talking about the pressure rise due to sudden closure of valve. This is also called as the instantaneous closure of the valve. So first, let's know little about the instantaneous closure or sudden closure. When a valve is suddenly closed in a pipeline, the rapid interruption of flow causes a sudden increase in pressure in the upstream section of the pipeline. This phenomenon is commonly known as water hammer or fluid hammer. The pressure rise resulting from the sudden closure of valve can be significant and may lead to adverse effect on the pipeline system. The pressure rise due to sudden closure of the valve can occur in a rigid pipe as well as an elastic pipe. First, we'll talk about the rigid pipe. So, in a rigid pipe, for a sudden closure of valve, the valve of the value of T is small and a wave of high pressure is created. In this situation, the liquid gets compressed to some extent and pipe material gets stressed. That is, loss of kinetic energy can be given in this case equals half of m v square equals 1 by 2 rho a l v square, and the gain of strain energy equals half of stress times of strain times of volume equals so on equating equation 1 and 2, that is loss of kinetic energy equals gain of strain energy 1 by 2 or AL gets neglected, half also neglected, so L square equals P square by K, or P equals V root over rho K, or this can also be written as K square is divided rho times of whole root. P equals rho V C, where C equals K is divided by whole root. So, which is the final equation to compute the due to closure of the valve for rigid pipe. Now let's talk about the pressure rise due to sudden closure of valve in elastic pipe. For this, let's consider a pipe of length L with diameter D and thickness T. When the valve is closed suddenly, wave of high pressure of intensity P will be produced in the water. Due to this high pressure, circumferential and longitudinal stresses are produced in the pipe valve, and the valve of longitudinal stress FL can be given as PD is divided by 40, and for the circumferential stress FC can be given as PD is divided by 2T, and the strain energy stored in pipe material per unit volume can be given as 1 by 2 times of FL square plus FC square minus twice of FL. FC is divided by M. Now placing the above value, these two value on this equation, considering the value of n equals to then this equation can be as 1 divided by 2 times of PD by 16 t square plus p square d square is divided by 4 square p square d square is divided by 16 t square. equals, simply on simplifying this, the result will be p square t square is divided by 8 e t square. Now total strain energy stored in pipe material equals strain energy per unit volume times total volume, and this can be expressed as p square d square is divided by 8 e t square, that is strain energy per unit volume is this, times of total volume is pi d t l. On simplifying this, twice of et. The loss of kinetic energy of water equals 1 by 2 m v square equals 2 rho a l v square, and gain of strain energy in water equals half of stress times of strain times of volume equals now loss of Ke of water equals gain of strain energy in water plus strain energy stored in pipe material. That is, this can be given as 1 by 2 rho a l v square equals 1 by 2 p squared by plus v square ADL is divided by twice of ET, or P square D is divided by, and simplifying this, P square by 2 times of 1 by K plus D by ET equals, that is, so simply, or P equals V root over rho is divided by K plus D is divided by ET, which is the to compute the pressure rise due to sudden closure of valve for elastic pipe. whereas the velocity of pressure wave for elastic pipe can be given as C equals 1 is divided by 1 by K plus D times of ET, or this can be expressed as K is divided by 1 plus dk is divided by et times of rho whole root, or C equals k dash rho, where k dash equals k is divided by 1 plus dk is divided by et is the final expression for the velocity of pressure wave in case of the elastic pipe. So for this time we end up the video up to this much. We'll come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.